true? So, oh, you can't see it. You can't see it. Good. So you use this unit circle on your test. Is that right? All right. So what I'm going to do now here is this. I'm going to share with you guys, this is a ray in standard position. We know that. And if I rotate this ray, let's say here to 30 degrees. Okay? This is where it's at. We can find sine, cosine, and tangent. Is that right? All right. So what if I were to rotate this ray then, not 30 degrees? Sorry. Instead, we rotate this ray. I guess I can't really do that. I'm going to rotate it 150 degrees. It's like, hey, come on, cooperate. Okay. There's your ray. We rotated 50 degrees. So if I were to say to you guys, if this was that first test, could you tell me what is cosine of what? 150 degrees. On the first test, how you use this, it was equal to x. Is that true? And how you used it was what? You look for the x coordinate. So you go, okay, Mr. Judge, that's easy peasy. I know how to do this. That x coordinate is what? Isn't it negative square root of 3 over 2? So you say, I know the answer. It's negative square root of 3 over 2. Good. That was on your first test. Outstanding. Okay, you just use the definition of the circular function and your chart. And that's good. Okay? However, I'm going to introduce you guys to another way to deduce this answer. Okay, you guys okay with that? And it's all based on quadrant 1. Where is quadrant 1? You guys know how to name the quadrants? Quadrant 1 is in your upper right corner. Quadrant 2 is in your upper left corner. Quadrant 3 is where? The lower left corner. Quadrant 4, ladies and gentlemen, is the lower right corner. So we do have another system, and it's not, you already know how to get these answers. You already had that on your first test. But it's all based on what I call quadrant 1 information here. Okay? It's all based on what you guys see here. Just so you guys know. Quadrant 1, which is geometry. So if you have knowledge only of quadrant 1, I'm going to say, okay, we have knowledge of quadrant 1. I'm not going to write it down, but okay. We know how to do with everything in quadrant 1. We can find cosine 30, 45, 60 degrees. We can find those 3 angles. This here is actually key. Okay? We're really kind of looking only for those 3 angles in quadrant 1. Knowledge of those 3 angles is going to help us answer all the other questions. Okay, you guys with me on that? So go back to quadrant 1, and this is like your reference. This is geometry. Okay, quadrant 1. Now, there's something called, if you've ever heard this before, All students take what? Calculus. You guys ever heard that phrase before? All students take calculus. Okay. You might say, why do they actually bring that phrase out? Well, you guys know why. In quadrant 1, what they mean is all three trig ratios are positive. So, is that true? How do you know it's true? Because your x coordinate is what? Positive. Your y coordinate is what? Positive. So your circular functions are all positive. Okay, you guys okay with that? Well, you say, what does the S stand for? Well, it's all students, but it really means sign is what? Positive. Only sign is positive in quadrant what? 2. Now you might say, why? Well, isn't sign the y coordinate values, right? So notice this, right? I'm going to try not to do it so big. Y coordinate, y coordinate, y coordinate. What about over here? Tangent is what? Positive. Why is tangent positive? Because, well, first of all, go back over here. The x coordinate is negative, but your y coordinate is positive in quadrant 2. Okay, this is why sine, which is the y coordinate, is always positive. Why is tangent always, and by the way, that means cosine's negative and tangent's negative. But why is tangent positive in quadrant 3? Well, because the x coordinate is negative, the y coordinate is negative, isn't tangent y over x? So the negative over a negative makes tangent what? Positive. So this is a nice system. All students take calculus. Okay. What about cosine? Well, in quadrant 4, the x coordinate is what? Positive. And the y coordinate's negative. Remember, isn't cosine the x coordinate? So what that means is cosine's what? Positive. All the other trig functions are going to be negative there, at least for the 3. Okay. All right, you guys okay with this? So if I go back to the original question, you say, Mr. Judge, what does this have to do with trying to evaluate cosine 150 degrees? Well, first of all, I want you guys to answer this question here. Which quadrant is 150 in? Which quadrant is 150 in? Is that quadrant 2? Is that right? Okay. So, because it's in quadrant 2 and all students, sine's positive, what do I know about this answer then? This answer must be what? Negative. Is that true? You already know the answer. But what I'm going to introduce you guys to, this is the first thing you have to do. Quadrant 2, cosine is negative. This is why you have this acronym, all students take calculus. Now, there's more to this story. You need a reference angle, a point of reference. A reference angle, ladies and gentlemen, is really a quadrant 1 angle. Remember I said it's all based on what you know in geometry, quadrant 1? Okay, let me give you guys a definition of a reference angle here, okay? So you need this reference angle. This reference angle is theta with that line. Reference angle. You guys okay with that? So let me give you the definition of a reference angle. And when you have that definition, you could use this system. Okay? Definition, ladies and gentlemen. A reference angle and to give you what your book gives you. There we go. Your book says this: let theta be an angle in standard position. That's really what you're looking at, an angle between 0 and what? 360. All right. Okay. And that's like the one, this is the 150 angle in the example. Okay. That's all. The reference angle theta with a bar that's associated with theta is the acute angle formed by the terminal side of theta and the x-axis. This is what the book says. Okay? So I just want you guys to know what the book says, because I'm going to give you really the way to find it. All right, you got an angle theta. That's the 150 degree. Okay? Reference angles associated with theta is the acute angle formed by the terminal side of theta and the x-axis. Well, here's what that is. Let me erase everything here. Okay, so you guys remember they're actually saying this. This measures what? 150. Is that true? Okay. What's that? What's the terminal side? Well, this is a terminal point. Okay. This is the ray. This is like terminal, meaning ending side. Okay. See that there? Where's your x-axis in relation to this terminal side? Well, what they mean by that definition is this is the x-axis. You guys okay with that? And really, it's the shortest distance from the terminal point to the x-axis. This is what they're saying. Isn't that the shortest distance? You guys okay with that? So you're always going to go to the x-axis, that shortest distance. The question, though, is what angle do you see here? This is what? What angle is that? You guys know? What is that angle? Could you tell me the angle? If this measures 150, that angle must be what? 30 degrees. Is that true? Why? Why is that angle 30 degrees? Well, together they're supplementary. They form a straight line. Is that true? So what you're really looking at is this is theta here. It's the angle that they have in question. So here's my theta. So you guys want to know in this picture for quadrant 2. We're going to start to get used to this. In quadrant 2, theta plus the reference angle is 180 degrees because they're supplementary. So why is this such a big deal? Easy peasy, ladies and gentlemen. This is called your reference angle. Okay? This is the reference angle. So if I know cosine of 30 degrees, and I do, you might say, how do I know what cosine 30 degrees was? Well, what is cosine 30? It's on our picture. Isn't that positive square root of 3 over 2? Quadrant 1? Okay. So if I know this, what's my final answer? Negative square root of 3 over what? 2. So you're using now the reference angle information. So cosine of 150 is negative square root of 3 over 2. But I know what you're thinking. You say, Mr. Judge, why did you just waste my time with this? Is that right? I have the unit circle. I can just look at where 150 is and give you the answer, right? Well, historically, people didn't have these pictures on their test. They didn't have that unit circle. You say, then how did they deduce the answer? Historically, ladies and gentlemen, people had to go back to geometry historically, right? Remember this 60 degrees, 60 degrees, 60 degrees. Historically, ladies and gentlemen, they had to go back here and say, if this is 2, this is 1, Pythagorean theorem, this is square root of 3. We bisected 60 and created what? 30. People had to memorize these special what? Triangles. So that cosine of what? 30 degrees from geometry isn't cosine? What did we use yesterday? Yesterday, we did these kind of things. What's cosine of this 30-degree angle? Remember the definition? Wasn't it adjacent over hypotenuse? And that was a square root of 3 over what? 2. So if you did not have that picture, you said, Mr. Judge, what if they take that picture away? Ooh. Go back to geometry. Go back to this special triangle. You say, what do you mean? Well, if cosine 30 degrees is square root of 3 over 2, all students take calculus. The reference angle is 30 degrees, right? That's why we got the reference angle. I can say cosine 150 is just minus now what? Square root of 3 over 2. Because now I'm looking at all students take what? Calculus on that unit circle. So in section 6.3, they ask you all these nice questions again. Can you tell me what cosine 150 is? You see what I'm saying? But without the picture of the unit circle. They just what? Tripped us up. No, they didn't trip you up. They're just giving you more additional information. You know, they kicked it up. So if I said to you guys, what if they want to know? What if they ask you, for example, sine of 120 degrees? They want you to evaluate that, okay? You might say, Mr. Judge, how do I really do this? Well, you think about this situation here, okay? If I were to determine, where is 120 at anyway? Quadrant what? How do you know? So this angle is what? 120. What's this angle? What's the reference angle? Is the reference angle 60 degrees? Is that true? You guys okay with that? So, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So you're going to do this. What quadrant is 120? Quadrant 2. Remember this. All students take what? Calculus. That is what you guys want to recall. All what? Students take calculus. So, if you can tell me what in the world is sine of 60 degrees, I can tell you what sine 120 is. You guys see what I'm saying? How do you find sine of 60? Use your what? Special what? Triangle. What is sine of 60? What's the definition? Opposite over what? Hypotenuse. Okay? Isn't sine 60? Here's my 60 degrees. Opposite over hypotenuse. Square root of 3 over 2. So, ladies and gentlemen, this is also what? Square root of 3 over 2. Which means sine of 120 is square root of 3 over what? 2. So it all comes down to the reference angle combined with quadrant 1 information. You're just looking right there at the summary of everything. So you answer 2 questions. What quadrant does the angle live in? Use all students take calculus and just know 2 special triangles. And notice, did I use that sheet? No. So, you guys ready for another example? Should I give you guys another example? What's tangent of 135 degrees? Okay. So, I might even have you go. Okay, you guys okay with that? Now, you guys can see 135 degrees is right here. Is that right? See if I can. Come on. Yeah. Guess I'll just use the line. See that 135-degree angle? That's 135 degrees. What you want to find is this reference angle. So you might say, Mr. Judge, for quadrant 2, is the angle plus the reference angle equal to 180? We need the what? Reference angle. What is theta? The angle is 135 plus my reference, and it better be 180, a straight line. If you solve for the reference angle, isn't that 180 minus 135? In other words, what do you guys get here? 45. See, you guys know what you're doing. That's 45 degrees. So you just found the reference angle. Okay. All right, you guys okay with that? Now, why is that important? Didn't we say use the what? Where do you get this 45-degree angle? Is there a special triangle? Do you guys remember? What special triangle do I use now? Don't you have this special triangle? 45, 45 what? 90? You guys remember that? If this is 1, this was a square root of 2 over 2. That was a square root of 2 over 2. This is your special triangle. So I recommend, ladies and gentlemen, highly recommend you memorize this what? Picture. You memorize this what? Picture. 2 pictures. 2 special what? Triangles. Only 2. Because tangent of 45 degrees is what? Right? Remember we said we got to find that reference, tangent 45. You guys remember what that is? Opposite over what? Adjacent. So if you did the arithmetic, what do you guys know? Isn't that equal to 1? So tangent 45 degrees is 1. Now that's not necessarily your final answer. Okay, now you're not done. You say, why aren't I done? Because what quadrant is this in? All students take what? Oh, it's already there. Sorry. Okay, do you guys see that here? See what I did? Okay, you guys see that? So what does that mean if it's an S? In quadrant 2. Quadrant 2 always is S. Sine is positive, but that means tangent is what? Negative. So that means -1. So you got tangent of 135 being -1. So, ladies and gentlemen, this is back, but it's back in such a way that you don't use that sheet anymore. You use 2 special triangles. Now, don't worry. You say, Mr. Judge, what if they ask me for tangent of 138 degrees? Well, they're not. What if they ask me for a tangent of 140 degrees? They're not. What if they ask me for a tangent of 134 degrees? They're not. Why not? Because you only have 2 special triangles. It's going to come down to, ladies and gentlemen, like I said to you guys, quadrant 1 is what they're going to start to just ask you about. This. Now, they're not just going to ask you for, this is going to be your reference. So I'm going to color it purple. I like coloring purple, the reference angles. So these are going to be your reference angles. Okay, I'm going to say that again. These are your what? Reference angles. But they're going to ask you, really, the quadrant 2 versions, the quadrant what? 3 versions, okay? And the quadrant 4 what? Versions. You guys see how it has all that there? And you're going to use this. All students take what? Calculus. All students take what? Calculus. This is telling you the 3 trig functions that are positive. All students take calculus. Quadrant 1 again. What? What quadrant is this? 1. This is what? 2. What is this? 3. What is this? 4. All what? Students take what? Calculus. So, in the next test, are you guys going to have this sheet? We're going to get rid of it. And you go, oh, no, Mr. Judge. But you're going to have special triangles. Is that right? Like, wow. Now, how can you also check some of these things? Like, for example, tangent 135, right? In your calculator, what if I were to do this? What is tangent of what? 135. What does that equal? Negative what? -1. Okay. Anyway, so ladies and gentlemen, let's assign you homework not today but tomorrow, right? So we can get started more on working with this special triangle and then seeing the more Pythagorean identity stuff. Okay. So I wanted to give you guys some theory and foundation and definitions. Yes, question. You meant tomorrow, Friday, or what's today? Already. I don't even know the day. Is that? I guess it's Monday. If you want, I could put some homework for you guys, okay? So you could get started. And then I'll put homework for you guys. And then we'll go over and continue on when? Monday. Sorry. Sorry for scaring you. Said you got to be here on Friday. Oh, my God. I don't know the day. Okay, you guys, take care. Have a wonderful day. To all of you guys, we're going to continue with looking at our what? Reference what? Angles. And we're going to look at reference angles to evaluate these. Let me go back here. Let me repaint that because I paint this reference angle purple because we're going to evaluate these other what? Trig ratios. Okay? So I want you guys to understand something here about these angles. Okay? The angle 210 degrees, as you guys see here, and 225 degrees, 240 degrees. These are in which quadrant? What quadrant are those angles in, ladies and gentlemen? Let's bring some of this. Yeah, because we want to look at this situation. I think that's not the picture I wanted to bring in. I wanted to bring in the one that we... Okay. So let's remind you guys, what angle is 225 degrees, 240 degrees in? What quadrant is that in? What do you guys think? Do you guys see it here? Yeah, they're all, notice this, quadrant what? 3 angles. Last time we dealt with quadrant what? 2 angles. All right, you guys okay with that? So these are all quadrant 3 angles now. Okay, so you might say, well, why do we have to do that? Because if we're going to evaluate sine of those angles, even though we already know how to do it by looking at the terminal point, but by using reference angles, that's going to be important. Now, the reference angle, just to let you guys know here, for every one of these questions, okay, that's what we are looking for. That reference angle. So if I said the angle is 210 degrees, so we can find sine, we first have to do what? Locate where that angle is at. So let me do this. We can already see it here. So let's take our ray and we rotate. How many? What is this? How many degrees is this? 180. And then I have to add how much? So this angle that we just looked at measures 200 and what? 10 degrees. Okay? And that angle, ladies and gentlemen, what's this angle? Okay, because you say, Mr. Judge, how do we find the reference angle? Remember what the reference angle actually is. Okay? This is my terminal point. And the angle, right, associated from the shortest distance to the x-axis. Okay, here's my x-axis. The shortest distance, ladies and gentlemen, along that unit circle is right here. Okay, you guys with me on that? So I'm trying to get to the terminal point to the x-axis. So the question is, what angle is that? What do you think that is? How do I find that angle? Right? Because this is what they mean by the reference angle. So let me show you a formula for quadrant 3. For quadrant 3, this is the formula we want to know. Let's take a look at what I did. The angle theta for any quadrant 3 angle is going to be what? 180 plus my what? Reference angle. Okay, I'm going to do that again. If this lets me. This is going to be what? 180 plus a reference angle. Quadrant 3. Okay? And that's an important thing to know. Okay? So if I say to you guys, hey, what is the reference angle, right? You already know the angle theta is 210 degrees. So this is how we kind of want to think of that. So this becomes 210, which is 180 minus that reference. Okay? Oops, plus the reference. So if I subtract the 180 from both sides, ladies and gentlemen, what does that give me for the reference angle? 30 degrees is your what? Reference angle. So the reference angle equals what? 30 degrees. So ladies and gentlemen, there it is. It's a 30-degree angle. Does that make some sense? So that has to be, again, 30 degrees here. Okay? So you're going to use, for any quadrant 3, you want to use that relationship. And maybe for short, that relationship really is this. You can always say the reference angle will be always theta minus what? 180. So they're taking that equation, and what they're doing here, ladies and gentlemen, that relationship gives you the reference angle. Okay, now you might say, why do I care about finding that reference? Why do we care? Because we want to remember, what does all students take calculus mean? Right? What's that acronym? All students take calculus. We're focusing on quadrant 3. What does that T mean in quadrant 3? That means tangent is what? Positive. So sine and cosine will be what? Negative. Okay, so tangent is positive in that quadrant. So for the first question, they're saying, what is sine? Well, I don't know, but it's going to be what? Negative. Okay, because all students take what? Calculus. So sine of 210 degrees, which is what they want to know, is really going to be a negative answer. That's why we go with the all students take calculus. So now you say, Mr. Judge, but what's my answer? Well, you know what the answer is going to be? All you got to do is tell me what sine of what? 30 degrees is. That's your answer. So sine 210 is actually the same as minus sine 30. That's why you need to know the what? Reference angle. And then, what do I do next? Does anybody remember? Remember I said to you guys, all you need to know is 2 what? Special triangles. I still have them in my notes. So this is the special triangle. We only need to know two, okay? So ladies and gentlemen, what's the deal here? What's sine of 30? Do you guys know? Well, you got to know the definition. Sine, isn't sine going to be what? Opposite over what? Hypotenuse. So this here is replaced with what? 1/2. So the final answer, ladies and gentlemen, is going to be what? Sine of that 210 degrees equals negative 1/2. And you're done. And then that's it. There it is. And there it is. Okay, you guys okay with that? Easy peasy lemon what? Squeezy. What's the next one? Right? We're going to find now what? Cosine of 225 degrees now. So if I said to you guys, cosine 225, I'm going to write this down. Because all students take calculus, and tangent is what? Positive. What does that mean about cosine? Cosine has to be what? Negative. Is that right? So it's negative. But I got to know negative cosine of what angle? I need the reference angle. That reference angle goes here. So you might say, how do we know the reference angle? Well, this time, where are you at? Right? This time, ladies and gentlemen, that ray looks like this. You start in standard position, and you rotate to what? 225. So if I say to you guys, what angle then is this right in here? What's this angle? Is that 45 degrees? So, ladies and gentlemen, can I find cosine of 45 degrees now? The only way I could do that is if I know what? What's my special triangle associated with 45 degrees? I don't want that. I only want the triangle. Okay, so let's try to just get the triangle if I can. Just trying to get this here. Can I delete that? Yes. Okay, well, fine. Let's do it. Let's do a nice one this morning. Let's remind people here. Bless you. 45 degrees. Square root of 2 over 2. Square root of 2 over 2. This is 1. Okay, 90-degree angle. So what's cosine 45? Yeah, isn't it going to be, here's the 45-degree angle. The definition is adjacent over what? Hypotenuse. Here's the adjacent side. Here's the hypotenuse side. So this is just going to be the square root of 2 over what? 2. So that means cosine of 225 will be what? Yeah, it'll be negative square root of 2 over 2. There it is. There it is. All right, you guys okay with that? These are quadrant 3 angles. Okay. What do you need now? What's the next one? Tangent of what? Tangent 240, ladies and gentlemen. So let's go through tangent 240. Again, we said this is a quadrant 3 angle. Is that true? All right. Oops. Okay. Well, what do we know about quadrant 3 now? All students take what? Calculus. Okay. So tangent's positive. What that means is the angle will be positive. Is that right? Because it's tangent. But now you're at 240. So now we're over here. If we know the reference angle, shortest distance, we can answer that. What angle is that, ladies and gentlemen? This is going to be what? Is that 60 degrees? So this is going to be tangent of 60 degrees here. Now, in order to find tangent of 60 degrees, that's a special what? Triangle. This is a reference angle. So we got to go to 60 degrees. There we go. Here's 60 over here. Okay. Can erase this. So for tangent, what's the definition of tangent? Opposite over what? Adjacent. The square root of 3 over what? 1. You guys see that there for the 60-degree angle? So there's just 2 triangles we have to know. So this will be square root of 3 over 1, which is simply what? Square root of 3. So ladies and gentlemen, there you guys go. There it is. Tangent 240 is what? Square root of 3. Now this is for quadrant what? 3 angles. So last time we worked on quadrant 2 angles. What do you think will come next now? Quadrant 4 angles. Yeah, so we're going to look at this quadrant 4 angle now. Okay, so we're going to focus on quadrant 4. Now, you might say, well, what kind of angles are in quadrant 4? 300, 315, and what? 330. 300, 315, 330. So we're going to determine, let's do the following. How about if we say secant of 300? So that'll be question 4. Question 5, cotangent 315. Question 6, cosecant 330 degrees. You might say, oh no, should we try those or we should go back to sine, cosine, tangent still? Maybe we should do sine, cosine, tangent before we do these. I apologize. We'll do sine, cosine, tangent, and then we'll kick it up. And all of these angles now are quadrant 4 angles. I'm sorry. Thank you. Got to get that coffee in me. So let's go back and notice something here, okay? So if I go back here, and I'm going to erase this now. Here's the ray. We're going to rotate first to what? 300 degrees. These are quadrant 4 angles now. What was the reference angle definition, if you guys remember here? Your terminal point is here. Remember that? There's your terminal point. And then I have to get to the x-axis along that unit circle. So how do I get there? I got to have the shortest distance. The shortest distance from the terminal point to my x-axis is this way. Notice it's not the other way. That's longer. Is that true? So what that means then, this is how I find that angle theta. It's this angle here. Okay? That's the reference angle. This angle is going to be, generally speaking, my theta here. All right, you guys okay with that? Now let me share with you guys the relationship between the angles theta and the reference angle. So here's how this works, okay? Here's how you want to look at this. All right? You're going to do this. You're going to rotate one full revolution, which measures 2 pi radians, or 360, okay? So that's 360. That's my theta. Well, that's 360. And then I'm going to back up what? This reference angle. Okay, so you might say, what's the relationship between these here? Well, theta is going to be the following for quadrant 4. Theta equals 360 minus the what? Reference angle. So we rotate 360 and we back up the reference angle. Now, algebraically speaking then, right? So if this is going to be, for example, 300 degrees for that first question here, right? 300 degrees. We're going to try to find the reference angle. That's the key. How you get it, ladies and gentlemen, will be what? The reference angle, actually solve for the reference angle, and that'll be 360 degrees minus the theta. Okay, so my reference angle, algebraically speaking, is if I know, and I do, the angle they gave me. I know that they gave me 300 degrees here. I just have to know, what is 360 minus 300? Is that 60 degrees? 60 degrees. Okay, so you go, oh, that reference is 60 degrees. So let's go back to that circle. I want to make sure you guys can see this here, right? Because what they're saying here is that this here is what? 60 degrees. So focus on the 300 degrees. Notice, isn't that true? That if I take what? 300 degrees and I add 60, that's that full circle, that's 360. So this is how we find the reference angle for quadrant 3. So the formula changes depending on the quadrant you're in. Okay, so this is a quadrant 3 representation here. So if you change the quadrant, you change the formula, and then all students take what again? Calculus. So if I go here and you go, okay, if I find it, I'll just bring another one in. There's that 300. So what does all students take calculus actually mean again? Do you guys know? What does that mean? Yeah, cosine is what? Positive. So it means that cosine in quadrant 3 is positive. Sine will be negative. Tangent will be what? Negative. Right? All students take calculus. Sine is negative in quadrant 4. Tangent's negative. Cosine's positive. So here, this will be negative. This will be negative. But we already know the reference is what? 60. So, ladies and gentlemen, let me copy this here so you guys can see. This is what we're doing. Here's sine of 60 degrees. So what's sine 60? It's the definition of sine. Opposite over what? Is that right? What sine is it? Is it opposite over hypotenuse? So what's the hypotenuse in this case? Good. Square root of 3 over 2. So this will be, ladies and gentlemen, square root of 3 over 2. Here's your final answer. Okay, so, but it'll be negative. Yes. You guys see that? Sine of 300 is negative because in quadrant 4, sine is negative. That's all. That's it, ladies and gentlemen. That's using the acronym of all students take calculus. Okay, we know cosine here. How do you think we'll find cosine? This one's pretty simple. Well, isn't cosine going to be cosine? What's the reference angle for 315? 45 degrees? Good. You may say, Mr. Judge, how did you find that one? Right, how do we find that one? We'll go back. Where's the formula here? Do you guys remember the formula? Quadrant, no, that's quadrant 3. Where's quadrant 4? There we go. $315. Oops. Oh, go back here. Sorry. I think we have to write it. I didn't write it in black here, right? So the reference angle will be 360 minus the angle. So this is the formula you guys want to know. 360 minus the angle. All right. So my reference angle will equal 360 degrees minus, now the angle is 315 degrees. This is a different question. So you're right, my reference angle will be what now? It'll be 45 degrees. You're right. So this question here, this is why we said it was cosine what? 45. And what do we know about cosine 45? Anybody know anything about that cosine 45 degrees? It is square root of 2 over 2. And it's positive, right? Final answer. Well, why is that? You have a special triangle of 45 somewhere, right? Cosine here is going to be what? Adjacent over hypotenuse. So cosine here is the square root of 2 over 2 divided by 1. So I just want to write that down, and we have it already here. So, ladies and gentlemen, there we go. That's how you find quadrant 4 angles. Okay, let's do tangent of what? 330. How do you do tangent 330 now? Well, we know it's going to be negative. So let's find the reference angle, right? 330. So I'm going to write this down here. That formula for that quadrant 4 is 360 degrees minus what? Theta. So what's your reference angle now, ladies and gentlemen? This is going to be what? Is that 330? Okay. So the reference angle will be what now? 360 degrees minus 330 gives you, what does that give you? 30-degree reference angle. So this is going to be, I'll copy this so you guys know. It's going to be negative, right? I'll write that down. I just have to know what tangent of what? 30 degrees. Well, it will be negative. Yeah, we just have to. So what we're going to do is we're going to have to try to find tangent of 30. But yeah, it's going to be what? Negative. Absolutely. But you got to know tangent 30. So you say, okay, what's my tangent 30? Go to your special triangle. Tangent 30 is going to be what? Yeah, 30 degrees. Definition, right? Opposite over what? Adjacent. 1 over the square root of 3. So, let's do every detail. This is 1 over the square root of 3. Yes, it's negative. But you're going to now have to do what now? Rationalize the what? Denominator. Square root of 3 over square root of 3. Which gives you, what does that give you? Yeah, minus square root of 3 over 3. Okay, you guys okay with that? So, in summary, here's the summary relationship with reference angles. Quadrant 1, okay, the reference angle is the angle. Quadrant 2. So we're going to have to go all the way back. to what we did the other day. I hope I didn't erase everything. Okay, if I did, let's go back here. Okay, where's the formula? I might have erased it, but if I did, I'll bring it back. Yeah. Oh, no, wait. Here we go. Okay. See this here? I'm going to copy it. Okay. Because we're going to summarize that for you. That's 180 minus what? Theta. You say, how did you get that? We subtracted theta from both sides. Okay, so that's for quadrant 2. So that was the other day. Quadrant 3 and 4 we did today. So quadrant 3, where are you, quadrant 3? There we go. And then quadrant 4. So the last one we just did right here, 360 minus theta. So we can find the reference angle every time, provided we know the angle theta with these formulas. So we can even label that. Let's label it. Let's name it so we're aware. This is our reference angle. Right. Now, you might even say, Mr. Judge, what if they give me radians? What if this is what? Pi. Pi, they gave me radians, right? What's 2 pi? 360. So you even have the radian version. All right? Okay? So if you look at your homework, what happens if they say something like this? They want you to find sine, ladies and gentlemen, of maybe seven pi over 3 now. Okay, this is kind of simple. I think this is easier. You might say, what do you mean this is easier? You guys happen to know. I'm going to say this to you guys. A couple of things here. Here's the big question. What is the reference angle? This is easier. What do you think the reference angle might be? See this here? This is pi over 3. So the reference angle here, yeah, it's going to be pi over 3. That's your reference angle. Yeah, it's 60 degrees. However, this is the real question. Note, What quadrant is 7 pi over 3? What quadrant does that live in? We need to know the quadrant of that. How do we find that quadrant? So what angle do you think that is? There's a couple of ways we could do that. Yes. Isn't that 60 degrees, ladies and gentlemen? Is that right? Do you guys happen to know what's 7 times 60? Isn't that whole didn't you just convert this? That's 420. So double check. Are you guys okay with that? Isn't the angle theta going to be 420 then? Because 7, that's a multiple of pi over 3. Okay, you got a multiple. 7 times pi over 3 is really 7 times 60, which is 420. Now, you might say, Mr. Judge, that's really just asking me for the sine of what? 420 degrees. Is that true? How do we get sine 420? Isn't that outside of 360? So what do you think we have to do, ladies and gentlemen? Let's put things together. You take 420 and you subtract 360. Is that true? What does that give you? 60 degrees. So what this is really saying is, this is actually the sine of what? 60 degrees. Okay? So sine of 60 degrees here. Do you guys happen to know what sine of 60 degrees is? Right? The original question is, what quadrant does this live in? What's the answer? Quadrant what? 1. Good. So if this lives in quadrant 1, what do we say here? In quadrant 1, the reference angle is the angle. So all you got to do is know what sine 60 is. All you got to do is know your special triangle. What's that special triangle for 60? Here you go. What's sine 60? Yeah, we got to go to the definition, right? So 60, what's the definition of sine? Opposite over hypotenuse, square root of 3 over 2. Because this is sine of 60 degrees. I'm going to get rid of this highlight. Square root of 3 over 2. See, we have to have that one triangle. So square root of 3 over 2. So ladies and gentlemen, you could even put this together with coterminal angles. So there is the work. There is the answer for this here. All right, you guys okay with that? Every detail. So it's putting together the work we did with the coterminal angles and everything else. Cosine of maybe 5 pi over 3. Okay? So I got news for you guys. I know my reference angle here, believe it or not, is this factor here. This is pi over 3. Now, this here is going to be what? N 5. 5 pi over 3. Okay. What's pi over 3? 60 degrees. What's 5 times 60? 300. So this is cosine of what? 300 degrees. Cosine of 300. Well, that's... What quadrant is this in? Anybody know what quadrant we're talking about? Quadrant what? 4. Is that true? Ah, cosine 300 right in here. This is quadrant what? Quadrant 4. Okay. Bless you. So what's the reference angle? Do you guys know? 60 what? Degrees here. So you might even say, Mr. Judge, I don't want to even look at the picture to deduce it. Well, then you could go use the formula. You know it's quadrant what? 4. So the angle theta is what? 300. So could you guys tell me then, right, using this formula, what is 360 minus what, 300? 60 degrees. So sure enough, the reference angle is 60 degrees. Is that right? So we already know that by the picture, 60 degrees. So what that means is if I can find cosine of 60, then we are what? Done. Right, cosine of 60. So let's find out. Let's go to the special triangle here. Cosine 60. So we need to know the definition of cosine. What's the definition of cosine? Adjacent. Good. 1 over 2. 1/2. Here we go. Cosine 300 is cosine 60, which is 1/2. There you go, ladies and gentlemen. Is that easy peasy, lemon squeezy, putting everything together? All right. What if they gave you tangent of negative 5 pi over 4. This is all without a calculator, ladies and gentlemen. What's that? It was all too fast? Yeah. Okay. All right, well, let's try this out. Let's see if you guys remember. What's tangent of a negative angle? You guys remember something about tangent? Is tangent even or odd? Do you guys remember? I think it's odd. Is that right? Good job. What does that mean? Might want to. Should we close that door? Let's close that door. I'm getting scared over here. Huh? Yeah, I don't. I don't think people learn by screaming, ladies and gentlemen. I think people get startled by screaming. That's just my personal feeling. All right, well. Well, again, since they gave us radians, you know what's kind of nice and easy? You know, this is kind of a little trick so you guys know that this is my reference angle, by the way, pi over 4. You know, I want to just point that out to you guys. So you're going to be using that multiple, but this is really 5 times pi over 4. Pi over 4 measures what? 45 degrees. So 5 times 45. Even if you said, I don't even know what 5 times 45 is. Right? So we're putting all those little details together. That's actually 225, I think. But let's get out our calculator. 5 times 45. $225, sure enough. So this whole thing is 225 what degrees here? So let me kind of write it all down here so we can see this. Let's just keep that together. Minus tangent of what? 225. So we just have to know now what quadrant is 225 in. I think that's quadrant 3rd. Is that right? The 3rd quadrant. 225. Now, you might say, well, how do we know? We got this, all students take calculus. So 225 over here, quadrant, let me get that ray. 225. Quadrant 3. The reference angle is for quadrant 3 right here, right? So can you guys tell me what angle does that have to be? It's a 45-degree angle. Good. 45 degrees. And what do you guys know about tangent? Tangent is what? Positive, because it's quadrant 3. All students take calculus. So this is going to be a positive. So we're saying this tangent is positive. Okay. So I'm going to write down the details. This is minus tangent now of, since the reference angle is 45 degrees, this is what it comes down to. And yes, that original negative sign was out there. So if we can find tangent of 45, we got to go to this special triangle. What's the special triangle tell us for 45 degrees? Right? There we go. I think tangent is going to be what again? Opposite over adjacent. So the square root of 2 over square root of 2, right? And that's going to be 1, by the way. So it's 1. So here's my final answer. Yes, we had that negative, but it's negative times that 1 here. So the tangent is 1, but don't forget you already had that negative sign out there. So it's negative what? 1. All righty. So let's have you guys try a few here on your own, okay? Say determine, this doesn't really determine the, it's really called determining the exact value, but determine the trig ratio. And here we go. Secant of 10 pi over 3, number 1. Number 2, cosecant of negative pi over 4, 3. Cosine of 5 pi over 2, 4. Cosecant (5 pi over 6), 5. It's cotangent of 3 pi. All right, we're going to give you guys some time to try these out, okay? And we'll see how it goes. Let's get out the clock, though. Let's see what you guys get. Where we're at. Okay, now, remember what we were talking about yesterday, right? We left these off to do. Is that true? Okay, so let's try this out. Now, I do want to say a few things first, right? How I think you might want to approach this is to remember, what is secant? Isn't it the reciprocal of what? Cosine. So I'm going to write that as the reciprocal of what? Of cosine. Okay? This is the reciprocal of cosine. All right. Sorry about that. I'm just trying to get some things here. Three, 4, 9, 3, 3. Okay, you guys okay with that? Now, you might say, Mr. Judge, what do we do with this? Remember, your reference angle, by the way, I'm going to write that down this way, okay? Maybe go back to the color purple. That reference angle here is pi over 3. And so, what's that measure of pi over 3? Do you guys remember? What does that equal in terms of degrees? Is that 60 degrees? Okay, you got a 60-degree angle. Okay. All right, let's move that out of the way. Okay, so now, ladies and gentlemen, what does that mean about this value here, right? If it's 10, what is this? What's 10 times 60 degrees? Isn't this going to be now what? Is that 600 degrees? Okay, so I'm going to go through the whole thought process, and then in that unit circle here, right, I'm going to move this all out of the way Maybe it would have been better to, yeah, I guess we'll move it. All right, so we're going to go back here. Okay, we're going to have this here be 600 degrees here. So here's my point to you. Where on that unit circle is there 600 degrees? Right? What quadrant is 600 degrees in? Isn't that the kind of questions we have to answer if we look at all students take calculus? This is based on the quadrants. So how do you guys find, ladies and gentlemen, that information? 600 degrees, how do you find that? What am I really talking about here? What have you been working on, right? What do we need to know? What is, I'm looking for a phrase. What is a phrase? 600 degrees is what? It's coterminal to what? Anybody know? How do you find the coterminal angle? You take the 600 degrees, you subtract the what? 360. And what does that give you? 240 degrees. Good. So that is coterminal. So this here, I can really replace now that 10 pi over 3 with what? 240 degrees. So that's what this is going to become. It's going to be 1 over cosine, okay, of that 240 degrees now. Okay. And there it is. So 1 over cosine 240. So, ladies and gentlemen, 240 degrees, again, if I take that ray and we rotate, will be where? Over here. So, okay, now remember this. The angle here, the shortest distance from the terminal point to the x-axis is this route in purple here. Is that true? So that means I have my reference angle. We already know what that reference angle was going to be. What did we say it was going to be earlier? 60. So that's 60 degrees. Is that true? Okay, so what do we say here about this? So what I want to remark, what you can actually now do is this. We can say, hey, all I need to know then is 2 things. Cosine of 240 will be actually negative cosine of what? 60. Why? Does anybody want to tell me why that's the case? Why is it negative? Because what quadrant are you in? And what do you guys know about quadrant 3? Right? What's this saying again? All students take what? Calculus. So what that means is in quadrant 3, tangent is what? Positive. And it means cosine and sine are negative. So ladies and gentlemen, there you go. All right. So what's cosine 60? Let's go back here. You guys remember this special triangle? It never went away. What's cosine again? I kind of forget. Cosine of 60 is going to be what? Is it, it's adjacent over what? Hypotenuse. So that's, is that 1/2? All right. Look at that special triangle, ladies and gentlemen. So, okay. So that's going to be here. So this portion here we found, this portion is really what? 1/2, okay? So All right, let's put this all together. So it's 1 over negative 1/2. So what is 1 divided by negative 1/2, ladies and gentlemen? Do you guys know what's 1 divided by negative 1/2? I guess this is time for some S. You might say, Mr. Judge, what does the supplement portion mean? Well, if you ever have a whole number divided by a fraction, right? What does that mean you do? That's A divided by what? B over C. What is that? A times C over B. Is that true? So what this means is this is really 1 divided by negative 1/2. You are doing arithmetic. This is a whole number divided by a fraction. This is pre-algebra because it has a sign number, negative sign. So what is 1? Okay, you say that's 1 times a negative what? 2 over 1. And that's 1 times negative 2. What's 1 times negative 2? It's negative 2, your final answer. So ladies and gentlemen, there it is. So hopefully you guys got negative 2 yesterday with that one. And again, we're doing a little bit of that S. The answer is negative 2. Easy peasy lemon what? Squeezy. So this here equals negative what? 2. Okay, you guys okay with that? Anybody have any questions on all the gory details? I am using every bit of the skill sets we discussed, especially over here when we talked about what? What? Terminal. You guys remember that? When do you guys want to do your homework? It is never the night before, ever. Because if you guys notice, we're using all the skill sets we talked about. All right. Okay. We're going to do this again. You say, good. Isn't this kind of where we left off? Is that right? Okay, so what's the definition of cosecant now? It's the reciprocal of what? So that's sine of negative pi over 4. Let's see if you guys remember, is sine even or odd? Sine is odd. What does that mean? Right? What does that mean about, since sine is odd, what do we do with this sign? Don't we pull it out? Is that true? Because sine is what again? Sine is an odd function. So we're using all of those little details that we worked on. Okay, do you guys happen to know what's really pi over 4 anyway? Is that 45 degrees? You guys okay with that? So it's going to be 1 divided by what? Negative sine of what? 45. Okay. So what's the good news about sine of 45? Right? You guys remember, there's only 2 special triangles you have to know. There's only 2. Okay, so what are we looking for again? Sine of what, 45 degrees? Okay, so what's sine of 45 degrees again? What's the definition? Opposite. Okay, over hypotenuse. Is that true? Opposite over hypotenuse. So what's that going to be? Right? Is that just the square root of 2 over 2? Right? So if you said opposite over hypotenuse, let's kind of go over that detail. One over negative. You say, is that square root of 2 over 2 divided by 1? Now remember, anything divided by 1 is itself. Is that true? So what I can just really do is say, is that 1 over that negative square root of 2 over 2? And the answer is yes. Okay, because if we focused on the arithmetic of dividing any number by what? By 1, it's itself. So now we're going to go back to the S portion, and you say, what's the S portion? You have a whole number, A divided by a fraction. Is that right? A divided by that fraction. You keep A, you flip it over, and you multiply. So, all right. So, okay. So we're going to say here, let's remember this. Okay, we'll do it that way. We're going to say, okay, 1 divided by negative what? Square root of 2 over 2. Isn't that going to be 1 times what? Negative 2 over square root of 2? And what's a positive times a negative? So it's negative 2 times the square root of 2. Is that right? So what do you do now? Yeah, what did we work on before? You guys remember that? Okay, don't you have to rationalize? How do you guys rationalize, right? We went over those little details. Square root of 2 over square root of 2. Is that right? So you get negative 2 square root of 2 over 2. Because remember, at this point, don't you just multiply across here? Right? And then what happens with this 2 here? It's negative. So you get negative what? Square root of 2. Okay? All of those details we actually went over. Do you guys agree? All right. Okay, now let's take a look at this here. Now, I gave you guys a very interesting situation. This is a special situation. Why do you guys think this is special? Let me share with you guys this here, right? Is pi over 2 really a reference angle? If I asked you guys, what quadrant is this angle going to be in? Because pi over 2, what's pi over 2, by the way? 90 degrees, is that right? And then you got this multiple of 90, 5 times 90. What do you get? This is cosine of 450 what? Degrees. So what kind of language you guys think I'm going to look for here now if I said to you guys, what am I going to say now again? Because that circle, the unit circle, does not have 450 degrees. Is that true? You said, sure it does. Well, let's bring one in. Okay, I'm going to bring another one in here. Let's bring it in. So you say, well, where's 450? We don't see 450 anywhere. Is that right? Okay, so what am I getting at here? What do I have to do with this angle here? What do I need to look for? What's the word again? Co-what? What's coterminal? Right? We take 450 degrees, and what do? Subtract that 360, and you end up now with what? 90 degrees. So this question becomes, really, what's the cosine of 90 degrees? Okay, you guys okay with that? So when you look at your ray now, you take that ray and you rotate how? 90 degrees. You might say, Mr. Judge, I don't even have a special triangle for this, right? And you're right, you don't have a special triangle because there is no special triangle. There is no reference angle because this is a very special situation. You say, what's the situation? Remember, reference angles are quadrant 1 angles. 90 degrees is not on any quadrant. It's on the what? Y-axis. Is that right? You say, how do I know? You're looking at it there. So what do you guys think you would have to do to answer this question? Anybody know? What do you guys think you'd have to do? What do you guys think? Anybody know? We need to know what do we need to know? What's the definition of a circular function? Is it the x-coordinate or the y-coordinate? For cosine. So what's the answer? 0. There you go, ladies and gentlemen. Easy peasy, lemon squeezy. It's that x-coordinate. It's 0 right here. It's not in the first quadrant, right? It's not in any quadrant. You say, how come it's not in a quadrant? You guys know why it's not in a quadrant? Because in order to be in a quadrant, you can't be on that x-axis or the y-axis. So there's quadrant 1. Over here would be quadrant 2. You're not on a quadrant. You're not in a quadrant. And there it is. Okay, you guys okay with that? Number 3. Number 4 now, ladies and gentlemen. What is the reference angle here, right? Well, before we even do that, what's the definition of cosecant again? It's the reciprocal of what? What is it? Sine. Now, you might say, hey, Mr. Judge, where do I find those definitions again, right? Well, remember, we derived them, actually. They're in your notes. And the trig cheat sheet, remember this trig cheat sheet? Cosecant is 1 over what? Sine. Isn't it on the cheat sheet? All right. Okay, so you say this is 1 over what? Sine of that 5 pi over 6 now. What's this reference angle? Pi over 6 is really what? Is that 30 degrees? So that's going to be your reference angle. Believe me, let me show you what I mean. Okay, because you take 5 times that number, and what do you end up getting? This is 1 over what? One over sine. What's 5 times 30? It's 150 degrees. Okay, you guys okay with that? Now, you don't even care about coterminal. Why don't you care about coterminal? There's a very good reason why we don't care. Why do you guys think we don't care about this here? Huh? There's a good reason. Because 150 degrees is, in fact, what? It's in that circle here. It's in this unit circle. It's between 0 and what? 360. In fact, 150 is here. And even better, since all students take calculus, this angle is in what quadrant? All students take calculus. It's in quadrant 2. What do you guys know about sine? It's positive. Is it true, since this distance here from the terminal point at 150 to the x-axis, there's the shortest distance. Is it true that this angle is going to be what? Isn't that the definition of your reference angle? So this is a 30-degree what? Angle. All right, so now you have 1 over what? Sine 150 degrees. Isn't that the same as what? It's 1 over sine of what? 30 degrees. This is why we look for that reference angle. Because the reference angle is always going to really be going back to your point of reference. This is what we mean by that. All you got to do is know what these trig ratios are in terms of quadrant 1. Okay, that's why you always find that reference. That's 30 degrees. So you need to know, that's why we call it a reference angle. That's right. We always go back to that first quadrant, which is your point of what? Reference. It's like your compass. It's like your home base. You always go back there. So that's why everything here, this is why we say 30 degrees for the reference. Well, there is no reference if you're on the axis, but we know about 90 degrees. It's on that unit circle. Oh, the reference over here is 45 degrees. See why I keep it purple? It's consistent. So we just have to know now, what is sine of 30? So I have to go back to my special triangle. There's only 2 special triangles you guys have to know. What are they? The 30, 60, 90 and the 45, 45, 90. Not this one. Going back to over here. What are we looking for? I think we're looking for what? Sine of what? Sine of 30 degrees. What's the definition of sine of 30? It's going to be, what is it? Sine is what? Opposite over what? Hypotenuse. So it's 1/2. One over what? 1/2. So this here is going to be that 1/2 value. Now go back to the S portion I said. Isn't that 1 divided by what? 1/2, which is what? 1 times 2 over 1, which is 1 times 2, better known really as what? 2. There you go, ladies and gentlemen. The answer is what? 2. Okay. So there you go. So this answer really is what? This is 2. This is the whole point. So I am using everything that we talked about. Everything. All right. What's cotangent? Do you guys remember? It's a reciprocal of what? If I go back here, it's a reciprocal of tangent. Okay. But now we have to remember, what's the value of pi here? Isn't that 180? Okay, so we have really, since pi is 180 degrees, what's 3 times 180? It's 540. Okay, you say, wait a minute. 3 times what? 180 is really what? 540. Okay. What do we do with that angle? That's not in our unit circle, is it? No, isn't it bigger than 360? All right, so what do you do then? Right, what's the word I want to use again? We have to find what is what. What's that word? Co-what? Co-terminal. So we take 540 degrees, and we subtract what? 360. What did that give you? Anybody know? What's 540 minus 360? So you say, I don't even know. Okay. 540 minus your 360 degrees. What do you got? 100 and what? 80 degrees. Now, let's remind you guys. 1 over tangent of 180 degrees. Okay. So 180. So what do you think that means now? Let's bring in our what? Wait, no? Here we go. So we're going to have to, let me try to make this bigger. So we're going to have to really be careful here. I want you guys to note here that tangent of any angle, wasn't that defined to be y over x? So cotangent of any angle is a reciprocal, and that's x over what? Y. So that this whole question really is the same as cotangent 180. Is that right? Is that true? Because it was cotangent. The question was cotangent. This is really 180. Right up here. That was 180 degrees. Okay. So, ladies and gentlemen, then 180 is over here. We rotate the ray. X over y. Is that true? So, what do you think we're going to say? Is this going to be, this is what? Negative 1 over 0. That's what? So, what do we say here? This is going to be what? Undefined. You're undefined. So this is our answer here, undefined. So does that look a lot like the questions that we've been working with, ladies and gentlemen? Right? Does that look like the questions in your book? Okay, you guys with me on that? All right, because I'm looking at the book. Oh, I was. What happened to your book? Here we go. And in your book, we do have questions that look like this from Trig. Okay, so for example, let's go back to recall. We started this discussion on the Pythagorean identities. So if you guys remember, we got this Pythagorean identities here. And they're over here as well. So you say, well, where are they? Aren't they here? Didn't we work on this? Pythagorean identities, remember that? Sine squared theta plus cosine squared theta is 1. Tangent squared theta plus 1 is secant squared. 1 plus cotangent squared theta is cosecant. So we got our Pythagorean identities. All right. So under the guise of Pythagorean identities, all right, they're going to say this to you. Find the values of the trigonometric functions. From the given, what? Information. And so they'll give you some information, like for example, they're going to say maybe, okay, if cosine theta is negative, I'm going to say, let's say cosine theta is 3/5. Nope. I apologize. Negative 7/12. And theta is in quadrant, what? 3, okay? They're really asking for all 6 trig functions. Right? I believe they want to find all 6. So let me double check. Yeah, they're going to say, okay, here's find the values of the trigonometric functions. Let's highlight that. That means all 6. So you might say, whoa, how do we go about doing that? We're going to use a Pythagorean identity. Okay, so you say, well, what Pythagorean identity do we use? Well, which one can we use? If we are given cosine theta, which Pythagorean identity involves cosine theta? Do you guys know what I'm talking about? I see one. Here's what I see. Sine squared theta plus cosine squared theta, that will equal what? 1. Okay, you guys see the point there? I believe that's negative 7/12. Can't see that. Okay. So what you're going to need to do now is do a little bit of what? Algebra here. Okay. What they gave you as cosine theta is really what? Negative 7/12. So you plug in the negative 7 over what? 12 here. Okay, now, the algebra, this is the S portion again. So you might say, okay, Mr. Judge, what is it if you have a fraction and that's raised to the second power? What does that give you? That's a squared over what? B squared. Is that true? Do you guys remember that from algebra? So sine squared theta plus, you say, what is that negative 7/12 going to be? Isn't that going to be what? 49 over 100 and what? 44? Okay? And that equals what? 1. Okay? Because you might say, what is that? Well, that's negative 7/12 times what? What's a negative times a negative? Positive. What's 7 times 7? 49. 12 times 12. So that's where it came from. Okay? So you sit there and you say, well, I have this equation with sine squared. That means you can find sine. Okay? Because we have to find all 6 trig what? Ratios, trig functions. All 6, we only have cosine. So this is going to give us sine. And so good. You say, okay, we're going to get sine now. So you'll have to subtract, though, 49 over 144 from both sides. Yeah, what do you get? You get what? Sine squared theta is going to be what? 1 minus what? 49 over 144. What do you do with this number now? What do you do with this information here? Right. What are you guys looking at? This is again arithmetic with fractions, okay? So you're going to replace the number 1. What's the shortcut? With that 144 over 144. You got some arithmetic to do. So you have here, ladies and gentlemen, sine squared theta going to be 144 minus 49 over what? 144. Because you have the same denominator now. You get to subtract your numerators. So I want to just kind of remind people, if I go to the calculator now, to say, do you guys happen to know that 144 minus 49, what does that give you? Is that 95? So this is going to be sine squared theta going to be what? 95 over 144. So does anybody happen to know, how do we get sine from this? Anybody know? You got sine squared. How do you get sine? What do you have to use? Use, what do we call that? The square root what? Formula. Square root formula was sine of theta will be plus or minus square root of what? 95 over 144. Sine of theta will be plus or minus square root of 95 over the square root of 144. Is that right? Anyway. And what's the square root? Sine theta will be plus or minus square root of 95. What's the square root of 144? Do you guys know what that is? It's 12. Anyway. So I think this is going to be an important detail just to remind people here, right? What quadrant is your angle theta in, by the way? Quadrant 3. So what does that mean? Because you have two answers here. One's positive, one's negative. What does that mean about, what's a quadrant 3 angle? Right? So anyway, that's fine. Quadrant 3, what do you know? Your angle in quadrant 3 is really what? Any angle in quadrant 3 means tangent is what? Positive. So if tangent's positive, that means sine is what? Negative. Is that right? So I'm going to say sine here, ladies and gentlemen, will be negative what? The negative answer because it's in quadrant 3. So you got sine. Okay, and I think I'm going to leave it at that. But I guess no, we can do the rest, but let's get tangent and then we'll leave it at that. Okay, so we got sine, we have cosine that was given to us. The question is going to be, what about tangent? So if we go back and remember this one identity, right? What do you guys remember about tangent? Tangent is what? Sine over what? Cosine. Let's go back here. Okay, look at your sheet and remember if we can find that ratio here. Oh, there you go, the first formula. Tangent was sine over cosine. And we actually proved that, but okay. So you say, well, how do I get tangent? Well, you know sine, you just found it. What's cosine? It's negative 7 over what? 12. Okay, so let's see if you guys remember. What does it mean if you have A over B over what? C over D. Do you guys remember the algebra here? The arithmetic, you're dividing fractions. These are complex fractions. So A over B divided by C over D. So what does that give you now? A over B times what? D over C, which equals AD over what? BC. So you have negative, what's that? Square root of 95 over 12 divided by the second fraction, negative 7/12. Okay, so you keep the first fraction, you flip over the what? Second fraction. Negative times a negative is going to be a what? Positive. And what do you have now? Let's go to 95 over 12 times 12 over 7, and you're going to get the nice cancellation here. So you're going to have now tangent, ladies and gentlemen, and we're going to kind of leave it at that. Square root of 95 over 7 is that tangent theta. Anyway, we'll leave it at that. And there you go. Anyway, I just wanted to leave it at that, okay?